Look at a map of Saudi Arabia, and you see a country defined by vast deserts. But if you look for a single permanent river, you will find nothing, not a drop. It is a land of absolute hydrological silence, yet millions live here. The question is not just how they survive without water, but what they are paying in the future to keep the silence going. To understand this silence, we must first locate the anomaly. Saudi Arabia occupies roughly 2 million square kilometers in the Arabian Peninsula, a region dominated by the Rub al-Khali, the Empty Quarter, and the Hijaz Mountains. Geopolitically, this territory is the heart of the global oil market, controlling approximately 20% of the world's proven oil reserves. Yet, hydrologically, it is an outlier. While nations like Canada and Brazil struggle with water scarcity, Saudi Arabia possesses neither significant rainfall nor permanent surface drainage. The core tension driving modern policy here is the collision between a massive, energy-rich industrial state and a geological reality that offers no renewable fresh water. This isn't just a natural disaster waiting to happen. It is a managed crisis built on a foundation of ancient, finite resources. The absence of rivers is not a recent development caused by climate change, but a geological certainty dating back to the formation of the Arabian Plate. The landscape is fractured by deep faults that channel any rainfall directly into the sea, rather than allowing it to pool into rivers. When it does rain, which averages less than 100 millimeters annually in the interior, the water rushes into wadis, dry riverbeds that flood catastrophically during rare storms, but dry up completely within hours or days. There are no perennial streams. The only exception is a few seasonal flows in the far north near the Jordanian border, but these are ephemeral. The statistics define the severity of this aridity. The kingdom covers 2.15 million square kilometers, yet its total renewable water resources are estimated at less than 1 cubic kilometer per year. By comparison, Egypt, a country often cited as water-stressed, has roughly 60 times more renewable water. Saudi Arabia has 0 rivers because the topography and geology prevent surface accumulation. The land simply does not hold the water. This is not a temporary drought. It is the permanent state of the ecosystem. Here is where the pattern interrupts the history books. While other civilizations built empires around river valleys, the history of Saudi Arabia is written around the absence of them. The ancient Nabateans built their cities on wadis and relied on precise cisterns to catch fleeting runoff, but even they could not create a river. The modern state inherited a landscape where water is a transient visitor, never a resident. The silence of the riverbed is the defining feature of the geography, and it forces a specific, high-cost engineering response. Section 2. Fossil Water and the Desalination Gamble. Vervoort naar Semmer. Since surface water is non-existent, the state turned to groundwater, but the aquifers beneath the sand are not replenished by rain. They are fossil aquifers, trapped millions of years ago when the region was a wetter, greener place. The water currently being pumped is 20,000 to 30,000 years old. It is non-renewable. Once extracted, it is gone forever. The depletion rate is unsustainable. If current extraction continues, these aquifers will be empty by the middle of the century, likely between 2040 and 2060. To bridge the gap between zero rainfall and a growing population of 36 million, the kingdom became the largest producer of desalinated water on Earth. It operates hundreds of plants, many powered by its own oil wealth, converting seawater into potable supply. This creates a unique geopolitical dynamic. Saudi Arabia uses its energy dominance to bypass its hydrological limitations. It exports its water scarcity in the form of agricultural goods. Through virtual water trade, the country imports vast quantities of wheat, barley, and dates. Producing a kilogram of wheat in Saudi Arabia requires roughly 3,000 liters of water. By importing it from countries like Pakistan or Ukraine, where the water cost is a fraction of that, The kingdom saves its fossil aquifers for drinking while hiding its agricultural footprint in the diets of others. Here is where it gets really interesting. The economics of this gamble rely entirely on the price of oil. Desalination is energy-intensive, requiring massive amounts of electricity to run reverse osmosis membranes. The cost of producing a liter of water in Saudi Arabia is directly tied to the cost of energy. When oil prices drop, the subsidy structure that keeps water cheap for citizens and industries faces collapse. Conversely, when oil prices rise, the state can afford to pump harder and desalinate more, masking the depletion of the aquifers. This creates a dangerous feedback loop. The country is essentially spending its geological inheritance on a temporary fix, banking on the price of energy to remain high enough to sustain the illusion of abundance. But the aquifers do not care about oil prices. They are depleting at a rate that outpaces recharge by a factor of several thousand. The consequences of running out of water are already visible in the environmental degradation surrounding the capital, Riyadh. The city has expanded rapidly, draining the surrounding groundwater table faster than evaporation can return moisture to the soil. This has led to the drying up of ancient wells and the sinking of the ground in some areas, a phenomenon known as subsidence. The agricultural sector, once a source of local food security, is shrinking. Large-scale irrigation projects that once promised green oases are failing as the water table drops. The global significance extends beyond the kingdom's borders. Saudi Arabia's strategy of importing food while exporting water-intensive crops influences global trade patterns. The country effectively outsources its water stress to the global south, a practice that exacerbates water scarcity in neighboring regions. If the fossil aquifers run dry, the only remaining option is massive expansion of desalination capacity. This would require an unprecedented increase in energy consumption, potentially straining the power grid and increasing the carbon footprint of the nation's water supply. The geopolitical stability of the region could be threatened if water scarcity leads to competition over the remaining non-fossil water sources, or if the economic model collapses. The timeline for failure is tightening. With aquifer depletion projected to accelerate, the window for transitioning to sustainable water management is closing. The current model treats water as a commodity to be extracted, not a resource to be conserved. The silence of the wadis will soon be replaced by the sound of pumps working overtime, trying to extract the last drops of ancient rain. The transition to a water-secure future will require a fundamental shift away from the reliance on fossil water and a restructuring of the agricultural economy, a challenge that no other major oil state has faced with such existential immediacy. The silence of the rivers in Saudi Arabia is not a natural accident, but a countdown to a resource limit that humanity has yet to learn how to stop. Do you think energy independence can ever truly solve a hydrological crisis? Or is water the ultimate geopolitical constraint? If you find this kind of question worth asking, there's one every week here. The next video covers why the Caspian Sea is shrinking and how that affects the economies of 5 nations. And it's one you won't see coming.